So you're probably asking, well, out of all the atoms, why carbon? Well, carbon is a very versatile atom. Carbon can form four covalent bonds. Okay, so that's why carbon is extremely important for us. It can form four covalent bonds. If you remember from chapter 2, carbon has four electrons in the outer shell. The outer shell can fill up four more electrons, so therefore we can carbon can make four covalent bonds. Okay, um, I can also say in a way carbon can bond up to can bond up to four other atoms. Okay, because if it can fit four more electrons, it can bond with four other atoms. Also, carbon can bond with very important atoms, like for example, other carbons, hydrogens, oxygen atoms, and nitrogen atoms. And you will see a lot of these atoms in our biomolecules. And I told you from chapter 2 that these are kind of what I call the big four, right? Because that's in our bodies, we're made of a lot of carbon, hydrogen, oxygen, and nitrogen. Uh, Carbon can form all kind of structures. Okay, it can be in kind of in lines. It could be a line. It could be branched. They could do a bunch of branches. Branches can be branched. Um, Also can form rings. Okay, we'll call this carbon skeletons. These carbon skeletons or foundations, okay, or skeletons dash backbones. Okay, a backbone made of carbon, for example. It could be in the form of a line, it could be a branch, it could be the set of a ring, it can do double bonds, you can see double bonds and all that kind of stuff. So it's like I said, carbon is extremely versatile. What do we see here is a very simple compound. We see methane, which is carbon here, and as you can see, I will erase this again. I meant to do this. Carbon can do up to four bonds, right? And here is one, two, three, and four. In this case, carbon is being is bond to hydrogen, but could be other atoms as well. And also, the large organic compounds made of carbon are actually energy molecules. All right, so those energy, like in gasoline or important fuels in your body, for example, in food. So talking about carbon and being bound to or making a bond with hydrogens, let's talk about our first kind of carbon skeleton. And these are going to be mostly hydrocarbons. Whenever you see the word hydrocarbons, okay, this is a molecule that is made of carbon and hydrogen. So what's in hydrocarbons? Carbon and hydrogen. That's it. And because it's carbon and hydrogen, it's going to be nonpolar. And remember, nonpolar is because it's not charged, no charge. And we learned this in chapter 2. A carbon hydrogen bond is actually nonpolar. That means no charge. Why? Because both atoms are not very electronegative. So, they share equally, sharing electrons equally, share electrons equally. And if they share the electrons equally, they have no charge. That's it. And if they have no charge, then they're hydrophobic. In other words, don't like water. Cannot hang out with water. And like I was saying, so the thing about carbon is it can do a lot of different forms. We can have linear chains, branch chains, rings, single, double bonds. For example, here we see a linear. Okay, it's going to be example of a linear one. Um, It's a linear molecule here, or it could be branched, for example. Over here, this could be a little branched. You could also make rings like over here. You'll see this a lot with monosaccharides. And also, you can even see in them, carbon can make single or double bonds. For example, here is an example of a double bond. All right. And like I said, primary components are going to be, so what are made of hydrocarbons? Things like, for example, fats, fossil fuels, things that have to do with energy. And the reason why they're really energy rich is because of the bonds between carbons and carbons and carbons and hydrogens. Those bonds have a lot of energy.